Welcome back, everyone. To begin with the basics of PyTorch, we have to understand the fundamental tensor, which is a data structure used throughout deep learning. So we're going to cover in this lecture how we can convert normal NumPy arrays to PyTorch tensors, as well as how to create tensors from scratch, such as a tensor full of zeros or random numbers. Let's get started by heading over to the Jupyter Notebook. All right, we're going to begin by importing Torch, and then we'll import NumPy as NP. And then make sure you've activated our environment before running Jupyter Notebook. And to confirm this, you should be able to type out torch.__version__, or just tab autocomplete that. And when you run this, you should see 1.1.0. So if you don't see that, make sure you've activated our environment first, as discussed in the installation and setup lecture. Okay, let's first discuss converting a normal NumPy array to a PyTorch tensor. A tensor, recall, is a multidimensional matrix containing elements of a single data type. So what we're going to do here is create a NumPy array by simply saying np array, and then I'm going to pass in just 1, 2, 3, 4, 5 here. And so if I print out this array, I get back the actual elements in the array. I can check the data type in the array by saying r.dtype, and notice they're 32-bit integers. So right now you don't see a dot there because it's not floating point yet. And if we check the type of this actual object, it's a NumPy array. So if we have a NumPy array and we want to convert it to a tensor with PyTorch, what we can do is simply say torch dot and then say from NumPy and then pass in that object. And so here we can see the tensor, and the tensor now reports back not just the elements there, but also the data type for you. So it's now converted to specifically a PyTorch tensor, and it'll refer back to torch.integer 32-bit. So it gives you a little more information there. And you can also then assign this to some variable such as x, and then you can get x back out, or you can then also check the type of x, and it'll report back that it's a tensor within PyTorch. Okay, so the other option for converting from a NumPy array is to say torch dot and then call as tensor, pass in that NumPy array, and it reproduces the same thing. So this one specifically only works with NumPy arrays, and then as tensor is a little more generalized. Okay, so we already know how to grab the data type by simply spitting out the tensor. So if I asked for x, it will give me the data type. The other thing I can do is simply ask for the attribute .dtype, similar to a NumPy array, and it will report back the data type contained within that tensor. So what we're going to do now is let's go ahead and make a two-dimensional NumPy array. So we'll say R2D for our two-dimensional NumPy array, and we'll simply call np arrange, and we'll say from 0.0 to 12.0. And if we see R2D right now, it's just a bunch of floating point numbers from 0 up to but not including 12. And what I'm going to do is I will reshape this to be 4 by 3, and let's reassign it so it retains that reshaping. And here's now my two-dimensional NumPy array. So if I wanted to convert this to a tensor, as we just discussed, we simply say torch dot from NumPy, pass that in, and we can call this something like x2. And if I check out x2, now I have this tensor object, and note, it recalls that they're now floating point numbers 64-bit. So that basically means it has 64-bit precision on that floating point data. And you can check out the notebook that goes along with this lecture for a list of all the data types, such as 32-bit integers, 64-bit integers, and then various floating bits for floating point numbers, and then different 8-bit integers as well. But the main idea here is that we can get a NumPy array and convert it to a PyTorch tensor. Now, the last thing I want to point out is the two functions we just showed from NumPy and then as tensor. Those actually retain a relationship between the original NumPy array and the tensor that is spit out, even if you assign it. So what I want to show you by that is, if you take a look at this NumPy array, recall that we have this variable x, which we created from this NumPy array. Let's go ahead and take that NumPy array, grab an element from it, such as the first element at index 0, and then reassign that to be 99. So there's our original NumPy array, and 99 has been reassigned. Now recall that when we created this variable x, we used, if you scroll up a little bit, this from numpy command. And so this actually creates a link between this numpy array and this x, which often you may not actually want. So that means that since we affected our original array, if we take a look at x now, it has also now been affected. So it's actually creating a direct link to that numpy array. And often you don't want that link, you want the numpy array to be manipulated but not affect your tensor. So the most common function for converting a numpy array to a PyTorch tensor, even though you may see things like as tensor or from numpy, since that creates a direct link, if you do not want a direct link and instead you want a copy so that they're not sharing the same memory in your computer, what you're going to do is you're going to say just .tensor. So I'm going to recreate that array. We'll say numpy array here, and we'll say my array just to make it clear. We'll say np arrange. Let's go 0 to 10 here. So there's my array. Again, this is the numpy array. And what I'm going to do is say my tensor is equal to torch dot, and we're simply going to call tensor, and then pass in my array there. And let's go ahead and make one more variable called my other tensor, and we'll say torch from numpy, and then also pass in that array. So let's take a look at what we just created. We created my tensor, which looks the same, and then my other tensor, and these two right now look exactly the same. But the thing to note is that when we used .tensor, it created a copy. So it's actually no longer directly linked to my array. So let's prove that by grabbing the first element in my array, changing it to something really obvious as a difference. So now there's my original array. If we check out my other tensor, which was created using this from numpy function, and run that, we can see here that's actually been affected. But if we take a look at my tensor, which we used the torch.tensor command for, and we run that, that is actually not affected. That does not have a direct link to that original numpy array. Okay, so that's how we can create tensors from numpy arrays. Recall that we have two functionalities, as tensor and from numpy, and those will retain the link between the original numpy array and the PyTorch tensor. However, if you do not want that link, then you can simply use torch.tensor, and that will create a copy in memory so that things that affect the original numpy array do not affect your new PyTorch tensor. So we've learned right now the general ideas of converting a numpy array to a PyTorch tensor. What we're going to do in part 2 is actually learn about class constructors, essentially how we can create a tensor from scratch from within PyTorch. I'll see you there in part 2.